Hi. In today's lesson, we're going to learn about the difference between linear and nonlinear functions. All right, so the first thing we're going to do is we're going to practice graphing different functions and figure out how we can determine if it's linear or nonlinear. So before we do that, though, what does it mean to be linear? So linear means it's going to be a straight line. Nonlinear, therefore, would be not a straight line. Okay, so let's go ahead and let's look at the very first function. So we're going to determine if the function y equals negative 3x plus 5, is it linear or not? So in order to determine that, we need to graph it. So we're going to pick some values for x, just like we did in a previous lesson. We'll pick some values for x and substitute them into the equation and solve for y. So notice that they've already picked values of x for us, negative 1, 0, 1, and 2. So if x is negative 1, then we need to solve negative 3 times negative 1 plus 5. So that'd be 3 plus 5, or 8. Then we'll do it again. This time we're going to put a 0 in. So let me erase that y. So I get that y equals 0 plus 5, or just 5. If I do it again, do y equals negative 3 times 1 plus 5. So that'd be negative 3 plus 5, or 2. And then we'll do it one more. Negative 3 times 2 plus 5. Or negative 1. Okay, so now that we have a table of values, let's graph it. So I'm going to slide over here. They've already made a graph for us. So my first ordered pair is negative 1, 8. So I'm going to start at the origin. I'm going to go left 1 and then up 8. 1, 2, 3, 4, 5. So it'll be about there. 0, 5, don't go left or right, just go up 5. 1, 2, so that's right 1 and then up 2. And then 2, negative 1, right 2, down 1. And then I'm going to draw in a line here because those points do make a straight line. So this one, function number 1, is going to be linear. And let's highlight that. Okay, let's try another one. Let's look at function number 2. So this time we've got to graph y equals x cubed plus 1. So what value should we choose for x? So we can do the same thing that we did before. We started with negative 1, 0, 1, and 2. We can use those same values. So I'm going to come over here on the side and substitute that in. So I'm going to do y equals negative 1 cubed plus 1. Now, negative 1 cubed means negative 1 times negative 1 times negative 1, right? It means this, which is going to be 1 times negative 1, negative 1. So it's negative 1 plus 1, which is going to be 0. Okay, now let's try if I put a 0 in place of x. That'd be 0 cubed plus 1, which is just 0 plus 1 is 1. What if I substitute a 1 in there? Be y equals 1 cubed plus 1. Well, 1 cubed is 1 times 1 times 1, which is 1. So I'm going to do 1 plus 1, which is 2. We'll do it one more time. So this time we'll do 2 cubed plus 1. 2 cubed is 2 times 2 times 2, which is 8, not 6. So that'd be 8 plus 1, which makes 9. So now we're going to graph this. So the first ordered pair is going to be negative 1, 0. So I'm going to start at the origin. I'm going to go left 1, and then I don't go up or down. I stay where I'm at. So that's negative 1, 0. Now 0, 1. Start at the origin. Don't move left or right. Just go up 1. Okay, 1, 2. start at the origin. I'm going to move right 1, then up 2. So right 1, up 2, and then 2, 9. So right 2, up 9. So 2, 1, 2, 3, 4, 5, 6, 7, 8, which would be right there at the top. Now, when I draw this, this is not going to be a line. It's actually going to be curved, okay? So this is not linear. So I'm going to write non-linear right here, and I want you to highlight that as well. So the equation y equals x cubed plus 1 would not be linear. It's nonlinear. Let's skip to function number 4, because for this one we've got y equals 2/5 x. So for this one, it's probably not going to be as easy to use the same inputs since we're dealing with a fraction. I definitely want to use a 0. But if I put a 1 in place of x, it'd be 2/5 times 1, which is just 2/5. So this one, it actually might be helpful if I do a 5, because if I take a fraction and multiply it by its denominator, I'm left with my numerator. So I've got the 5, and I'm also going to do negative 5 here. Okay? I don't know if I could do 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try and see if we can fit 10 up there. All right, so now I'm going to come over here. That goes for the previous problem. So if I do y equals 2/5 times 0, well, that's 0. Then we'll do y equals 2/5 times 5, which would be 2. And you can put this in a calculator also. Then I'm going to do y equals 2/5 times negative 5, so that should be negative 2. And then let's do y equals 2/5 times 10. So that's going to be 4. Okay, let's graph it. So my first ordered pair is 0, 0, which is at the origin. Then I have 5, 2. So I'm going to move right 5 and then up 2. 1, 2, 3, 4, 5. And then negative 5, negative 2. 1, 2, 3, 4, 5. And then 10, 4. So that's right 10, 6, 7, and then up 4. 2. I think it's right there. Okay? And so this looks like it's going to be a straight line. You could put a ruler and it will be a straight line, which means that this one is linear. So I want you to write linear right there. Okay? Okay, so what I'm going to have you do is I want you to go ahead and do functions 3, 5, 6, and 3, 5, 6, and 7. So pause the video and complete those just like I showed you, and then we'll check. Good luck. All right, welcome back. So hopefully you did well with this. Remember, you're just determining whether or not the function is linear or nonlinear. So notice function 3 is nonlinear because it's going to have that curve. Function 5 is linear. It's going to be that straight line. And we've already talked about how to graph vertical and horizontal lines. And y equals any number is always that horizontal line. Function 6 is nonlinear, it's going to curve, and function 7 is a funny looking type of function, but it's also going to be nonlinear. You would not be able to draw a straight line for that. So in looking at the types of functions that were linear, we should notice, hopefully you notice a pattern. They're all going to be in that y equals mx plus b form. So function 1, function 4, and function 5 were my linear functions, and they can all be written in slope-intercept form, which brings us to our next page. So linear functions are always going to be in the form y equals mx plus b, or they can be converted to that form. So m being the slope, b being the y-intercept, and the graph is going to be a straight line. And then as far as the table goes, so that table, when you're talking about a linear function, it's going to have that constant rate of change. So if I'm looking at this table, as I go from -3, I'm on the x side, from -3 to -2, I'm adding 1 again, adding 1. So as I'm moving up, I'm adding 1. On this side, I added 2. Okay. So the constant rate of change is going to be 2 over 1, 2 over 1, 2 over 1. So think about the slope between any 2 points. It's going to be the same. If this table was not exhibiting a linear relationship, then I would not have a constant rate of change. Okay, and then the type of graph that you're going to see, you might see a graph such as this, okay, or that's an increasing graph. This type of graph would be decreasing, that negative slope. You could also see a horizontal line. Now, the vertical line, this is linear, but not a function. Linear, I'm going to write that, linear, but, and it's not a function because it doesn't pass the vertical line test, which we learned about in a previous lesson. So it's linear, but not a linear function, just to be clear there. Okay, so how do you know if a linear equation is increasing or decreasing? So when we see increasing, I want you to think positive slope. And when you see decreasing, think negative slope. So in the equation, how do you know if it's going to be increasing or decreasing? So look at the slope. If m is positive, we are increasing. Remember, m stands for the slope. If m is negative, then it is decreasing. Okay? So that's how you can tell from an equation. How can you tell if a graph is increasing or decreasing? Well, if the slope is positive, if it's a positive slope, meaning uphill, think about slope, dude, then we would say it is an increasing graph. If your slope, or m, is negative, think about slope, dude, going downhill, then we say it is decreasing. Okay, just as simple as that. So let's look at some equations. And it says determine if the equation is linear or nonlinear. Tell how you know. And if it is linear, is it going to be increasing or decreasing? So let's look at the first one. Y equals 1/3 x plus 3. Linear or nonlinear? This one is going to be linear. And how do we know? It is in the form, let me write in y equals mx plus b form. It's in slope-intercept form. Is it increasing or decreasing? So to tell that, we want to look at our slope. So our slope is positive 1/3. So this is increasing, and we can say we know it's increasing because m is positive. All right, let's try number 2. Is number 2 linear or nonlinear? This one is going to be nonlinear. And how do we know? It is not in slope-intercept form. And we can also see x is the exponent. X. And I want you to write that down too. So since it's not linear, we're not going to answer the increasing or decreasing question. Okay? So now you're going to do problems 3 through 9. So pause the video and complete problems 3 through 9. Remember that if it's not linear, then you don't need to answer the increasing or decreasing question. You can just put an X through them. All right, so pause the video and do those now. Okay, so hopefully you did well with this. You're going to want to pause the video so that you can check your answers. Here are the answers to problems 3 through 6. And then here is 7, 8, and 9. And I want to talk about number 8 really quick. So with number 8, for this one, it is linear, but the part about is it increasing or decreasing, it's not going to be increasing or decreasing, and that's because y equals 1 is the graph of a horizontal line, which means we have a slope of 0. So it's neither increasing or decreasing. All right, let's look at the next section. So now we've got some tables, and it says to tell whether the table represents a linear or nonlinear function, and if it's linear, tell whether or not it's increasing or decreasing. So remember, when we're looking at the tables, you're going to look at the rate of change for each little section. So the easiest way to do that is to do the x's and do the y's. So for example, from -3 to -2, I've added 1. From -2 to -1, I've added 1. From -1 to 0, I have added 1, and from 0 to 1, I have added 1. Now I'm going to do the same thing for the y's. From -7 to -5, I've added 2. From -5 to -3, I've added 2. From -3 to -1, I've added 2. And from -1 to +1, I've added 2. So no matter which way I take it, I'm going to have a slope of 2 over 1, right? So my slope is 2 over 1, or just 2. So it has a constant rate of change. So we're going to say that this is linear. And is it increasing or decreasing? So we know the slope is going to be 2, positive 2. So we would say it is increasing. Okay? All right, so now you're going to do problems 11. Actually, go ahead and do 11 through 18. 16 through 18 are graphs, and you have to answer the same questions. So pause the video and complete 11 through 18. Okay, so now you're going to check your answers for 11 through 18. Make sure that you've shown your work just as I have done here. If you have questions about any of these problems or any of the problems on this worksheet, be sure to contact your teacher. Once you've submitted this, then go ahead and work on your independent practice. Good luck.